Hi, today we're going to talk about dummy variables and using categorical variables in your regression model, be it ordinary least square or logistic, or other regression models. Now, when you have categorical variables and you're using dummy variables, you generally tend to have a reference group. So that's what we're going to discuss today. All right. Now, let's open the database. You can find the link under this video. And what we're going to try and explain today is let's think about a regression where we're trying to explain the number of children that a family has. Right? And so there's a variable here called V201, which is total children ever born in the family. Yeah? So we see that we have 935 observations, and this is the average or mean number of children that a household has in this data set. Now, so we just summarize this. This is the variable we'll be using, and I'm going to just generate a variable called children is equal to v201 so that I'm not messing around with the original variable here. So that's generated a variable. If you look at the bottom here, that's the variable children. So let's say we want to see how wealth affects the number of children that our family has. There is a variable here which is it's a categorical variable for wealth, and the wealth index is V190. So let's tabulate that, and what we see is that there are 5 categories for the wealth index. Now we can use the command code book to find out different categories in the wealth index have been coded. Yeah, so it goes from 1, which is the poorest household, to 5, which is the richest household. So as the wealth level increases for the household, the numeric values increase as well, right? So it's an ascending order. So if we were to regress the number of children a family has onto the wealth index, and I'm just going to put V190, and V190 is increasing in the wealth category. What we observe here is that we have 2 results that have been reported. One is the wealth index, and as it seems that as wealth increases, the number of children a family has decreases. Now there's another variable here which is constant. Now we didn't add that constant here in the regression. Well, that is added bias data by default. Yeah, and so what is this constant? Well, if you were to draw this in a graphical form, this is telling you what the intercept is on the y-axis, and this is telling you what the slope is. As wealth increases, how does it affect the y variable, which is children, and the wealth is on the x-axis. So this is the intercept. So let's see how this constant is created. Now, if I was to create a constant of my own, let's say a variable called constant, and if I say 1, that's really what the constant is. Stata is running a regression. It is trying to regress children on V190 and another variable which is ones, and that is what it is reporting here as constant. Yeah. So the command that you can use if you don't want Stata to use constant is, hey, run regression on children V190, and please do not include a constant. Yeah. So and when you do that, you see that it hasn't included a constant, and this is what you see as your regression result. Now, if you were to draw this on a graph, y and x axes, this is starting from the origin. Now, so what is this constant? Well, very easy to see. Regress children 190. Let's put the one that we have created, the constant, and so no constant. And we should have the same result, 3.73 here. It means that when Stata runs a regression, children on wealth, it includes another variable which takes the value of 1. Yeah? And that is reported as a constant. And this is just 1. So if you put other x variables that add up to 1, then there would be multicollinearity. We'll come back to that again. Right? So now what I want to do is, when you look at this result up here, and let me just do the default regression so that we can move on. V190, here we go. So what we see here is that it gives us a coefficient, right? So what this is saying is, if the wealth index, if the household moves from the poorest to poorer household, there's an increase, a change in the total children born by this amount, right? This is the coefficient. And we have restricted such that whether the family moves from the poorest, whether the family moves from the poorest to poor, change by 1, or the household moves from the middle income group to richer, the change in the total children born, it's the same. Yeah? So you've restricted that. Now, it would make sense for us to think that the change would be different when you move from poorest to poor household as compared to moving from, say, richer to richest or middle to richer income, right? So what we want to do is create dummy variables. And how do you do that? Well, you can tabulate V190, and we want to now generate, so let's put the command gen, let's call it WLTH, short form of for wealth. Okay, so now if you look here, we have all these variables that have been generated, and all these are dummy variables. We can check that by browsing our data set. Let's say, hey, can you please browse wealth, all the variables related to wealth. So this star is telling Stata to pick everything, all the variables that start with wealth. So wealth 1, 2, 3, 4, 5. And I also want to put V190 because I want to see, double check if this is correct. So what we see is for the richest household, wealth 5 takes the value of 1, yeah, and 0 otherwise. So all these are now dummy variables. Yeah. Now, if we were to include all this in our regression, reg children born, and we want to wealth 1 to wealth 5. And remember, we are asking Stata to regress children on these x variables. Stata by default is also going to put a constant, right? Now, what happens when you add all these x variables from wealth 1 to wealth 5? They add up to 1, which is the same as your constant. And hence what you have here is multicollinearity, and in order to avoid that, Stata drops one of the variable. Just to show you what I mean, let's just say what are we talking about, and let's just add these, right? Wealth 4 and wealth 5. So you've created a variable called what, and that is adding up all the x variables that you put in. Yeah. So now what I want to do is I want to browse all this. Yeah. So what we see is that the what is, it adds up to a value of 1, which is the same as the constant that Stata puts in by default. Yeah. So you have multicollinearity, and as a result, it drops 1. Run the regression without any constant. All right. Without a constant. Yeah. And so this is the regression. What we see is that, and now you are regressing it on wealth 1 to wealth 5. We don't have an issue of multicollinearity because we asked Stata to run this without the constant. Yeah. What happens when you include a constant? And I want to drop 1. I don't want Stata to choose 1 for me. I want to drop 1 myself so that I can control the narrative of this story. Yeah. And I want to drop the poorest household. So that becomes my reference group. So when you run this regression, what do we observe here? Well, the constant is 3.33, which is nothing but the coefficient of the wealth, one variable. So whichever you drop gets picked up by the constant. What about the other categories? Let's look at the wealth 2 category. This is minus 0.45, which is, what is that? It is 2.875 minus the wealth 1 category. So here, this coefficient is picking up. How does the coefficient for wealth category different from the one that you dropped, the reference group? Yeah, so now these results are in reference to the one that you dropped, which is the poorest household category. And this is the difference between wealth 1 and wealth 2. Similarly, when you look at wealth 3, that is the difference between your wealth 1 and wealth 3. What happens? Let's see what happens if you drop, instead of wealth 1, you actually drop wealth 5. So now you're turning the richest household as your reference group. So when you drop wealth 5, it is picked up by this constant. And now the coefficient for wealth 1 is the difference between wealth 1 and wealth 5. So it's 3.33 minus 2.28 and change. Yeah. So that's what this is picking up. So when you interpret these results, when you have categorical variables, this is telling you how, compared to the reference group, is the average different for this category. Yeah. So in general, which one should you drop? Whichever makes it easier for you to tell the story. Yeah. Generally speaking, for wealth, I like to drop the poorest because it makes sense for us to say, hey, as income increases, what happens to, yeah, as income increases, the number of children born in a household actually decreases, yeah, because this is a negative coefficient here.